Alright, so some of you guys asked me to put together a video talking about finding the orthocenter. What we need to remember is that the orthocenter is made up, it's found by connecting the altitudes of a triangle. An altitude is when you start at a vertex and you draw a line towards the opposite side and it's a perpendicular line. Vertex to the opposite side, it's perpendicular, altitude. Vertex, line to the opposite side, it's perpendicular, that makes that an altitude. Vertex to the opposite side, perpendicular line, makes it the altitude. Where all the altitudes meet, we call that the orthocenter. So that's the first thing that we got to get down. That the line that is made from the vertex to the opposite side is perpendicular to that side. It goes through the vertex and it is perpendicular to this other side. So we know that the altitude, this altitude right here, passes through this point. We know this altitude passes through this point, and I know this altitude passes through that point. So one of the problems that I asked you guys to do in class, well, what if you were given 3 vertices? These are the vertices of your triangle, and you're asked to find the orthocenter. So we can do it without graphing, but until we get good at it, I'm recommending that we graph. So I'm just going to plot them and then I'll slide it up. So I have -2, 2, which is right here. Again, I'll slide it up in a second. I got to be able to see my points. 6, 10, which is right there. We can call that y. And then 6, -6. And we'll call that point z. So all I did was graph my points. There's x, y, and z. And my points were -2 and 2. I hope y'all can read that okay on the graph paper. This point was 6, 10, and this point was 6, -6. So there's my triangle. There's my vertices. I'm going to connect my vertices. And I'm going to make it as pretty as I get. My 5th period got so happy today when I made a nice pretty triangle. And I'll try to do that now. Alright, there's my triangle. I'm looking for the orthocenter. I'm looking for the point where my 3 altitudes hit. Now I told y'all in class that usually they give you a nice triangle. Usually they give you a triangle that's pretty easy to work with. And they did it again here. Again, if I start at a vertex and I draw a line to the opposite side and it's perpendicular, that's an altitude. So hopefully we see an easy altitude that I can draw in. I'm hoping we see that if I go from point X and I go like this, there is my right angle. So that is an altitude. First altitude. I didn't have any work to do to find it. No algebra, just recognizing if I go from this vertex and I go towards the other line, I'm going to draw a perpendicular line. That's my first altitude. Now, what is the equation of that line? If it is a horizontal line, it's going to be y equals, and I'll try to make this dark so we can see. And where does it cross the y-axis? It crosses at y equals 2. So I have y equals 2. First equation of an altitude. So I've got one altitude, y equals 2. Now what I'm trying to find is where my altitudes meet. It's where they touch. So I have one altitude. I would like to be able to draw in the other one, or at least see it. But before I can do that, I have to have an equation. I already have one. I need one more equation. So before I can do that, I'm going to look for the altitude that comes from this point down. I'm going to look for this one. Before I can do that, I need the slope of this line, because if this is the side of the triangle that my second altitude is going to go through, then my altitude must be perpendicular to that line. That's what I'm trying to find. I'm trying to find the altitude that when I draw it from Z and hit this line, it's perpendicular. But I don't know how to do that until I know the slope of this line. Once I know the slope of this line, I will be able to get the slope of the perpendicular line. So the slope of this line, I subtract my y's on top. Again, it's going to be hard to see because of the graph paper that I have. M equals 10 minus 2. Subtract your y's, and on the bottom I got to do 6 minus negative 2. So 10 minus 2 is 8. 6 plus 2 is 8. 8 divided by 8 is 1. So the slope of this line, which again we could have just seen by looking at the graph, is 1. So my M prime, what I was calling it in class, the slope of the perpendicular line has to be equal to negative 1. Because the slope of a perpendicular line has a slope. If my lines are perpendicular, my slopes are negative reciprocals. I can multiply them together and get negative 1. Some of you guys might already see the answer, which is good. If you already can see the answer from either what I've already done or you saw it sooner, that's done. That's good. I don't have to do all this work. I'm just showing you where it's coming from. Now, if I am drawing in the altitude that is going to hit this line, then it must go through this point. Because the altitude starts at a vertex and it hits the opposite line at a right angle. So I know if I go into y equals mx plus b, and again I apologize, I hope you can read this okay on the graph paper. The point that I can put in is 6, negative 6. Because my altitude must go through this point if I'm using this line. If I found the slope of this line and wanted to find the altitude of this line, it would go through this point. But I chose this line, which means my altitude must go through this point. So let me just plug in y equals negative 6. My m we said was negative 1. My x is 6, and I get plus b. I have negative 6 equals negative 6 plus b. Hopefully we see that this means b is equal to 0. So the equation of my altitude, if my m is negative 1 and my b is 0, is y equals negative x. I could say plus 0, but I don't have to. So these are my two equations. I already knew that y was equal to 2. Now I know that y equals negative x, which allows me to solve for x. If I plug in this 2 where I see this y, I get 2 equals negative x. And if I multiply both sides by negative 1, I get negative 2 equals x. So I have my orthocenter. The x is negative 2 and the y was 2. Now, if anyone else already saw this, there was another way we could have done this. If we see here, this is a right angle right here. And we talked in class, whenever I have a right triangle and you are asked to find the orthocenter, it is always at the vertex of the right angle. So we had the answer all along. I'm going to stop this video. I'm going to find one more where I have to find the equations of both lines.